Okay, so this is one of the tricky homework questions that we've got of these three different spheres. It's quite a generic situation in the sense they all have the same mass and there's just a speed that's going towards it. I think this is going to link to something that we did 2 weeks ago when we were over in the other building, and it was looking at the proportions or the ratios of the speeds afterwards to help us spot some of these patterns. I think it's going to be something to do with that.
It's the same question, so.
Yeah? Yeah, it probably is. It seems like it's a really same kind of... It's the same question, isn't it? Okay, so we're going to do this one, and actually that definitely means I can do this one. Were you able to do it in the homework then, Sam?
To an extent.
To an extent, okay. So obviously we know with these kinds of questions to begin with, we just look at one of the... that's not worked very well, has it? We just look at one of the collisions first of all. This is going to be A and B. So if I just draw that diagram out separately that we have here, with M and with M, and then we have U here. We'll call this one X, and in fact I probably won't do X and Y because I know later on I'm going to start running out of letters, so maybe I'll start with V and then W here, and then when I do another collision I can do X and Y just so I don't run out of letters. Okay, let's go quite quickly through some of these things then. So PCLM is going to say that we have MU equals MV plus mw. In other words, u equals v plus w. And then Newton's law of restitution would say that E is equal to, what's the speed of separation? W minus v, and the speed of approach is u. So we get EU equals W minus V, and we're going to want to find out both of these things. So I think it looks pretty easy if W is going to be made the subject, so we get EU plus... Yeah, you could just add the two, so you could do that as well. Yeah, I mean, we can do that if you prefer. There's obviously many different ways you can solve simultaneous equations. I think I'm always in the habit of substitution, but you're right, you could just add these together. So should we just should we add them together just to show that there's other ways of doing it? So if we call that equation 1 and that one equation 2, if we add equation 1 and equation 2 together, you get EU plus U from the left-hand side equals 2W, because the V's will cancel. So you get a half U E plus 1 is equal to W. Can you just see that I divided by 2 and I also factorised by U at the same time? Okay. I'm now going to also try and find out what V is. So V, from this one, we know that V is U minus W. So V is equal to U minus this thing that we have, which is a half U E plus 1. I'm just going to come down the board bit here because we're going to have quite a lot of things that are happening. So we then get V equals U minus a half EU minus a half U. So V is U minus a half U is a half U minus a half EU. So V is a half U 1 minus E. Okay, so we've got these two things that are happening here. This is the bit where I think we might be able to do some quicker things that could possibly happen. And actually this is something I wanted to speak about, so I'm really pleased that we've brought this question up because I forgot about this from 2 weeks ago. I'm going to just draw out this thing that I have here. I'm just going to draw it out again over here, and we're going to try and spot some mathematical properties of things that are happening, okay? We have got a mass and a mass. This one is going at U. V is going to the right. Well, we think it's going to the right. A half U 1 minus E. In fact, do we know if it's going to the right definitely? Or could it be going to the left?
Definitely, no. Yeah, definitely.
Why is it definitely going to the right?
Because there's nothing to push it to the left.
Yeah, there's also, well,
Or go to the right.
there's actually, I was actually meaning more about this thing here we can tell. How do we know that this is definitely going to be going to the right? It's positive, because we know that E is less than 1. So this thing is definitely positive. And this thing is obviously going to the right as well, and it has a speed of W, which is a half U. I'm just going to change that from E plus 1 to just 1 plus E, so we start to see some of these symmetries of things that we've got here, okay? So if you look about what's happened, this value of U from the beginning bit has been halved and then multiplied by 1 minus E to get this speed afterwards. This value of U for the second one has been multiplied by a half, and then also multiplied by 1 plus e. So we've got those instructions of what's happened for that collision. Now what I'm going to do is try and have a look at what happens when this particle now collides with C. Let's just do C in a different colour. So this is particle C now, and we're going to try and find out what happens in this area, okay? So I'm going to draw that bit out again here. We've now got that this one is particle B, this one is particle C. They've got the same masses, but the speed that this one is coming along at is a half u 1 plus e, okay? Previously, we said whatever this one's speed is, to get its speed afterwards, you take its speed, you half it, and you multiply it by 1 minus e. Why am I allowed to repeat that process for this collision that we've got here? What do you mean they're all the same? Be more specific. They're the same spheres, and they've got the same masses. So this collision that we've got here we said it was u. Maybe u was, I don't know, 12. What happens to that is you get half of 12 and you multiply it by 1 minus e. This is now just a different u. It's not u anymore, it's a half u 1 plus e. So you don't need to do the whole thing. The reason you don't need to do the whole thing is because the masses are equal to each other. And actually, I'm really pleased this has come up, because this has come up as the part E of the last question of the entire thing, of the entire mechanics paper. And it will ask you for a 1-mark question to say, what would the speed be after 3 more collisions, or something like that, or after 2 more collisions. And it's about trying to spot this pattern. So what we were actually thinking is going to happen here for this one's speed afterwards is you will have, I'm going to just write it out really long for a second to try and make it really obvious what's happened. There will be a half, which is this bit that we've got here. Then we're going to have this thing, which is the u part, which is going to be a half u 1 plus e. And then it's also going to be multiplied by 1 minus e. So this is what we think the speed of B should be afterwards. And then we're going to have a look at what C is over here. Well, we know that there's still going to be the half from the previous bit. The u, though, is whatever this u was here, which is a half u 1 plus e. And then we've also got the 1 plus e, which is from this bit that we've got here. So simplifying these two speeds that we've got afterwards, this simplifies to a quarter u 1 plus e 1 minus e, and this simplifies to a quarter u 1 plus e squared. Okay. Now we could, let's say that this particle C, let's do an imagined situation. Let's say that there was an imagined particle D which had a mass m. We could make another prediction about what would happen if C was going to collide into D. If I just really, really briefly have a look at this, this is obviously beyond what the question is asking. We know that C is coming across with a speed of a quarter u 1 plus e squared. Let's just predict what speed D would be going at. Anyone think they can predict what they think D would be going at? Good. An eighth u 1 plus e cubed. The relationship between that speed is the same as the relationship between that speed, and the same as the relationship as between that speed and that speed that we have there. Similarly, we could work out what this speed here would be as well. I know this orange is perhaps a little bit difficult to see, but what do you think the speed of C would be after the collision as well? An eighth u 1 plus e. I don't think it would be 1 plus e squared, because the thing that gets introduced is a 1 minus e. And here we had a 1 minus e was introduced. So you'll... Oh, I'm so sorry. Yeah, you're completely right. 1 plus e squared, 1 minus e. Sorry, Ashrek, you're completely right there. So we can start to see these patterns of things. We're allowed to do these repeated patterns because they have the same masses and because they're at rest. So it's like the same scenario is happening again and again and again. This looks like a really, really busy kind of board that we've got here, but I suppose the main thing, this part of the diagram up here is the main thing, where the speeds are changing, and to find out the speed afterwards, you're multiplying it by a half 1 minus e and a half 1 plus e. So this orange bit, obviously we went a little bit beyond the scope of what the question was. Find the speeds in terms of U and E after this, of the spheres after these two collisions. So that looks like we would say after both of the collisions, let's then say the speed of A, let's get out the orange pen for a second. What was the speed of A after the collision? After the first collision, because it doesn't change, does it? A half U, 1 minus E. That comes from this bit here. Remember, this is particle A. So it was U, and now it's a half U, 1 minus E. The speed of B, this is now after the second collision, because B is after the whole thing. Which is the speed of B after the second collision? A quarter U. Good, it's 1 plus E, 1 minus E. And then the speed of C is the one that we have down here, which is a quarter U, 1 plus E squared. It's a really difficult question because I think the temptation from all of the previous learning that we've done, the temptation is just to do PCLM, NLR, PCLM, NLR. And it just gets, you can probably get there, but you have to spot you have to spot some factorizing and stuff that's happening there. So my board isn't exactly the neatest of boards that we've got there. That's only part A. It then says, show that A will catch up with B and there will be a further collision. So after the second collision now, B has hit C. We now want to know if this one is going to catch up with this one. What do I need to do if I'm going to try and see about if there's going to be a collision between A? What do you mean to factorize it?
Do you create an inequality?
Yeah, we want to create an inequality. So we think that A, if there is another collision, this is for part B, if A catches with B, catches with B doesn't make any sense, does it? If A catches B, the speed of A has to be greater than the speed of B. And so the speed of A we think is a half U, 1 minus E. And then we have a quarter U, 1 plus E, 1 minus E. We can cancel the U's from both sides and the 1 minus E's from both sides. So we have a half is greater than a quarter, 1 plus E. What could I do to both sides of the equation?
4 on both sides.
Not times both sides by 4, so we get 2 is less than 1 plus E. And so you get that E is less than 1. So this tells me if A catches up with B, then the speed of A has to be greater than the speed of B. The speed of A will be greater than the speed of B when E is less than 1. So is the speed of A going to be greater than the speed of B? Yes, because E is always less than 1. Because E is less than or equal to, well, I think it says in the question it's less than equal to 1 actually. I think in the question it says it is not equal to 1. So because E is actually not less than or equal to 1, yeah, because E is less than, I'm doing the same thing, because E is less than 1, the speed of A is greater than the speed of B, so it catches up. I'm really, really, really pleased that you asked about that question because I think it just, it kind of illuminates the power of like the mathematical like ratios of these kinds of things that happen here. I think it's quite an interesting sort of thing to be able to spot. It's pretty tricky though to spot these things. Does this thing up here that we talked about, are there any bits you want to say, hang on, why did you do this bit? Or what's this thing that's happening here? Or were you okay with it?
Are there any conditions like that you can spot those? Does that have to be just the mass and that is stationary?
I imagine, and I would probably want to try this out with something, if this one had a mass of m and this one had a mass of 2m, and then this one had a mass of 4m, I imagine that the ratios would still end up, the ratios of the speeds would end up as being the same as the ratio of the speeds for the second one, because the ratio of the masses were in the same from 1 to 2, and then from 2 to 4, 2 to 4 being the same as 1 to 2. So I think that that same pattern would happen as long as each collision was effectively the same collision, if you know what I mean. So as long as they're in the same proportion of masses, you should have the same ratios of speeds afterwards as well. That's kind of the implication of this. Okay, so what we're going to have a look at is I'm actually going to do the first part of this question I want you to do on the whiteboards, and then when we get to the harder part of the question, we're going to come back together and we're going to do this part together, okay? This is actually in your textbook, I think. It's in the review exercise, and I think it's review exercise 2, question 16, but my question looks a bit different because I took it from an old textbook. But you've also got this printed in your booklet as well. So the things that I want you to do on the whiteboards for me is part A, part B, and part C of this question here. Okay, I'm going to leave that on the board for a little bit. And then we're going to come back together and we're going to think about doing part D and part E, which basically brings us to the end of this part of the topic. Okay?